All right. Good morning, Carol and Zay. Are you there?
Yes, I'm here.
Why is your camera off?
Oh, okay, I'll turn it on.
Good. Zaylin Pugh, where are you from? From Myanmar?
Yes, I'm from Myanmar.
Okay. Carol, how about you? Carol, are you there? Philippines. Okay. Good. Zaylin, where do you live? In Yangon or in Mandalay?
Yangon, sir.
Okay, very good. Nice. Nice to meet you guys. I also actually lived in Myanmar for 6 years, and I was a math teacher and department head at Horizon International School. If you have ever heard about the school, it's in Port Saint Road, Naidishkinta. Anyway, guys, good to see you. So today we are going to talk about linear inequalities with you. Okay, you know that in math, two different types of things. Number one is equations, and second one is inequalities. And also we have linear equations, and here we are going to talk about linear inequalities. Okay, and as you know, in math, we have four inequality signs, right? The first one is greater than or less than or greater than or equal to or less than or equal to. If any algebraic expression, right, that involves one of these symbols, we call them inequality, right? So how about when you just say linear? When you just say linear, we mean that we are talking about this kind of inequality, right? A times x plus b, either greater than 0 or less than 0, or greater than or equal to 0 or less than or equal to 0. In math, why do we call this expression linear? Because all variables, unknowns, here we have only one unknown that we are going to talk about with you today, and every unknown here is multiplied by a constant number. So here that x is unknown, right? Here this a and b, we call them either parameters or just constants. They are given numbers, okay? So today we will just consider some different types of inequalities. They are all linear. How do we solve them? As you know that in math, actually to solve the equations or what is it, equations, any problem, right? We need to know some properties, some rules, okay? So now before we start this, let's have a look at the properties of inequalities. What are the properties? Starting from the first one, we know that if a minus b is greater than 0, right? That means that a is greater than b. And on the number line, what do we mean by a is greater than b? If we just position them on the number line, so if here we have b, so a must be positioned to the right of a, right? So that's why we say that if every number is to the right of another number, so that number is greater than that number. But here, our number is b, our number is a is positioned to the right of b, that's why a is greater than b. Or in different expression, how can we express this? Also, we can say that b is less than a. Okay, the second one says that if a minus b is less than 0, that means that a should be less than 0. Why? Because here a is positioned to the left of b. Okay, how about the second property? If a is greater than b, and that means that b is greater than a. As you see here again, as you see here, if b is less than a, or a is greater than b, because sometimes one thing we can express in different ways, right? For example, Zaylin is Carol's classmate, for example, or Carol is Zaylin's classmate. They mean the same thing, right? If you just interchange things, and also a is greater than b, that means that b is less than a. All right. How about the second thing? Number 3, if A is greater than B and B is greater than C, that means that A is greater than C, right? So that means that again on the number line, for example, let's say A is greater than B. What does it mean? That means that this is B, right? And here we have A. That means that A is positioned to the right of B. And how about B is greater than C? That means that B is positioned to the right of C, right? A is greater than B. Okay. So B is positioned to the right of C. That means that C is on the left of C. So our C is somewhere here. So from here, we can see that, as you see here, A is positioned to the right of C, and that means that A is greater than C. I mean, when we're just talking about this, we call them actually algebraic manipulation, right? Anyway, A is greater than B. Another important inequality, I mean property, if A is greater than B, and if you just add the same constant number or something to both sides, it does not change the inequality, right? We are just adding. Because addition actually in math, what does it mean? It means that we are just translating, right? Or moving this AC units either to the right or to the left, right? For example, let's say here we have 5, okay? What is 5 plus 3? That means that I need to shift this 3 units to the right. 1, 2, 3. So 5 plus 3 is equal to 8, right? And how about 5 minus 3? That means that I need to shift this point 3 units to the left. 1, 2, 3. So here 5 minus 3 is equal to 2. That means that here, if A is greater than B, and if you just shift A, C units to the left or right, in the same way, if you just shift B, C units to the right or left, actually this inequality does not change. Anyway, how about property 5? Here, if A is greater than B and C is positive, right? And AC is also greater than BC. That means that it's also very important inequality if A is greater than B. That means that another example is, let's say 5 is greater than 3. And I'm saying that if you multiply both sides by positive number, still actually it does not change this inequality sign. Multiply both sides by 7, for example. 7 times 5 is greater than 7 times 3, right? 7 times 5 is 35. 7 times 3 is 21. Carl, how old are you? Are you 13 or 14? Carl, why don't you speak?
I'm 12.
Zainin, how about you? How old are you?
I'm also 12.
12. I see. Good. And number 6, if A is greater than B and C is less than C, right? And also, as you know, that if we multiply both sides of the inequality by negative number, we have to change the direction of inequality sign. As you see here, greater, now it becomes smaller or less. It's like, for example, let's say we know that 5 is greater than negative 2, right? Now, if I multiply both sides by negative 3, for example, what happens here? Multiplying both sides by negative 3, 5. And here we have negative 2. Also multiplying this by negative 3, right? That's actually, I'm not sure about which one is greater, but if you evaluate this, negative 3 times 5, it is negative 15. And negative 2 times negative 3, it is 6. And we know that every positive number is greater than negative number. So negative 15 is less than 6. And that's why in inequality, when you multiply both sides by negative number, or if you divide both sides by negative number, also you need to change the direction of inequality sign. And the last property is, if A is greater than B and B is greater than 0, and C is greater than D, D is greater than 0, then AC should be greater than BD. That means that we are talking about, I mean, 4 numbers. We know that A is greater than B, C is greater than D, right? So if you multiply bigger number by bigger number and the smaller number by smaller number, the result of the product of bigger numbers will be greater than the product of the smaller number. All right, guys, now let's talk about solving inequality. What does solving equation or solving inequality mean? We know that, for example, when you're solving equation, so we need to find such x, right? For example, let's say, how do you solve this equation? 3x plus 1 is equal to 7, for example. Solving equation means that we need to find such value for x. When I substitute that value for x, right, the left-hand side should be equal to right-hand side. And how do you solve this? First, I should take 1 to the right-hand side. So here we have 7 minus 1. Actually, we are not taking 1. We are just subtracting 1 from both sides. So now here we have times x, 3 times x is equal to 7 minus 1 is 6. Now if I divide both sides by 3, or if I multiply both sides by 1 over 3 and 1 over 3, right? So on the left I have x, because 1 over 3 times 3 is 1. And on the right hand side, here we have 3, here we have 2. So what do we mean by x equals 2? Actually, by applying a bunch of properties right here, I'm just adding something to both sides, or subtracting something from both sides, multiplying something, both sides by something. In this way, I have converted this equation into this form. Now, the value of x is displayed here very explicitly. I can see it, x equals 2. But in this equation, I cannot see that. Solving inequality also very similar, but instead of equal sign, now we have inequality sign, and using those properties, we have to transform the given inequality into this simpler form. Okay, so a value of x which satisfies an inequality is called a solution of the inequality. Then we are talking about one solution. And the set of all solutions of an inequality is called the solution set of the inequality, because usually inequality has a lot of solutions, and that's why we call them the set of, solution set of the inequality. And sometimes we can just, for example, let's say solution set. What is it? For example, all numbers greater than 1. Or another solution set, for example, all numbers that is less than negative 1 over 2. And solution set, for example, let's say all positive real numbers that is greater than 0, right? And this kind of thing. And solving in a linear inequality, again, solving means that by applying a bunch of these properties, we have to change it into the simplest form. And we have x alone here. Solving linear inequality is essentially a series of transformations to obtain the solution set finally. What are the series of solutions? Transformations. We are talking about this. Just applying the properties that we have seen in the previous, slide. Zaydin, Carol, do you understand everything? Or if you have questions, guys, you can raise your hand and ask, or just stop me and we can have more discussion.
Okay.
Good. So now let's start with very simple question, inequality. Okay, solve this inequality. On the left, we have x minus 1 over 4 is greater than 2x plus 3 over 3, right? And we know that in inequalities, if you multiply both sides by a positive number, it does not change the inequality sign, right? So what number we should multiply both sides by? What number we should multiply this? Let me actually see here in the denominator. Here we have 4. In the denominator here we have 3. So I'm going to multiply
12.
both sides by such number so that we will not have any fraction in the inequality. What is that? It is least common multiple of 3 and 4. That's equal to 12. So let me multiply both sides by 12. Here, I put right here 12, and also here I write 12. And what is 12 times 1 over 4? That's equal to 3. So here we have 3, and x minus 1 is greater than. And how about 12 times 1 over 3? And that's equal to 4. Here we have 4, and here we have 2x plus 3. Now, first we have to expand this. 3x minus 1, right? 3 times x, 3x times 3 times negative 1 minus 3 is greater than 4 times 2x. It is 8x. 4 times plus 3, that is 12, right? Now, we know that in equations, right, in solving equations, then after that, we have to take all the unknowns to the left-hand side and constants to the right-hand side. Also, inequalities, the idea is the same. Now, here, we have 8x. I need to take this to the left-hand side. Here we have constant. I'll take this to the right-hand side. Actually, I'm not taking. I'm just by maybe subtracting 8x from each side and adding 3 to each side, right? If you just add 3, for example, on the left, we have negative 3 plus 3. That's equal to 0. And if you subtract 8x, for example, on the right, 8x minus 8x, that's equal to 0. So here we have 3x minus 8x is greater than, and 12, and this negative 3, right? If you add 3, so here we have 3. On the left, negative 3 plus 3, that's equal to 0. Now, what is 3x minus 5x? That's equal to negative 5x is greater than 12 plus 3, that's equal to 15, right? So now I want to isolate this x. I want to leave x alone on the left-hand side. So what should I do here? I need to eliminate this, right? So what is the reciprocal of -5? If I multiply -5 by -1/5, that's equal to 1, right? In general, on the left, if we have a over b, I need to multiply by its reciprocal. So that is b over a, so that the answer will be 1, okay? So here, let me multiply both sides by -1/5. Or simply, I'm just dividing by -5. Here we have -5. So if you divide by -5, since I am dividing by -5, right? And also here we have 15 over -5. Now also we need to change the direction of this inequality sign, because if you multiply by negative number, if you divide by negative number, we need to change the inequality sign or direction of inequality sign. So it becomes less than. So -5, it is gone. So here we have only x less than 15 over -5, that's equal to -3. So all the numbers that is less than -3 will be the solution of this inequality, right? On the number line, if you just illustrate your answer on the number line, here we have -3, and all the numbers to the left of -3, right? All the answers are here. So that is the solution set of this inequality. Water, please. Okay, Zainin, is everything clear?
Yes.
Good. All right, then let's move to the next example. Solve the following inequality for x. Okay, that is a little bit tricky. And in general, we know that if we have something like this, x plus a is equal to x plus, let's say not x here, y plus a, right? And we said that if you just add, right, the something to the left and to the right, the same thing, it does not change anything. But here, when we're talking about inequality, also it works for inequality. But as you see here, for the first off, when you are dealing with math questions, you should not immediately start solving it. Okay, first have a look. And if possible, reorganize the question and change this into a little bit simpler form, then start solving it. Now, at the first glance, as you see here, this expression, right, and that is algebraic fraction, and also on the right, algebraic fraction, they are exactly the same, right? So I can just remove them, but under one condition. What condition? That is, if that thing is actually defined, that means that if x is not equal to 5, right? That means because if x equals 5, 1 over 5 minus 5, the 5 minus 5 is 0, 1 over 0. In math, we do not have zero division operation, right? We cannot divide any number by 0. Such thing is not defined. And that's why, just keeping this in mind, now I can cancel them from both sides, right? Because they are exactly the same thing. Because also inequality is something like, I don't know, it's a kind of scale, right? Just removing the same mass from both ends of the scale. So what is that here then? Here we have 4x minus 2 is greater than, on the right, 3x plus 2. Now next thing is, take this 3x to the left. Here we have 4x. It changed its sign because it's changing its side. Minus 3x is greater than, here we have 2. Take -2 to the right. Actually, we are not taking, again, to eliminate this -2 from left hand side, I should add +2 to both sides of the inequality, right? If you add 2 to left hand side, -2 plus 2 is 0. On the right hand side, here we have 2 plus 2. 4 minus 3, it is x greater than 2 plus 2, that's equal to 4. But now, how can I write the solution? At the beginning, we said that x cannot be equal to 5, right? Because if x equals 5, this 1 over 0 is not defined. So also I have to consider this. Then the solution will be x is greater than 4 until 5. So here we have 4 is less than x less than 5, right? or or because you should pick the solutions either from this interval, or that is x is greater than 5. Okay, on the number line, just to visualize this, what's going on here? Here we have 4 empty circle, it does not include this. Here we have 4, and until here also these are the solutions, right? The solutions are here from here to here. 4 is not the solution, 5 is not the solution. Again, from 5 to infinity, continue. These are the solution sets, okay? Not including 4, not including 5. Okay, Zaydin Pugh.
Yes, sir.
Carol, any questions so far?
No, sir.
Okay. I have also a lot of Filipino friends, actually, we were together at university in Cambodia. That's good. Guys, if everything is clear, let's move on. Now we will consider a little bit more complicated stuff, okay? Not complicated, but it involves more different conditions. So here, after a linear inequality in one unknown is transformed to the form ax is greater than b. Every time we have to transform it into this form. We know actually number one, if a is greater than 0, right? If a is greater than 0, then I can divide both sides by non-zero number, and I will have here ax over a is greater than b over a, because a is greater than 0. This a cancel each other. Now the inequality solution will be this: all numbers greater than b over a satisfies the given, the original inequality. How about if a is less than 0? Again, we know that if you are dividing both sides by negative number, because here we are saying the negative number, and now we need to change the inequality sign, right? It was greater, now it becomes less than, because you are dividing both sides by negative number, right? For example, it's like this: negative 3x is greater than, for example, let's say 6. Now, if you divide both sides by negative 3, what I have here? So here we have x, right? Because negative 3 over negative 3 is equal to 1. And I need to change this inequality sign: less than 6 over negative 3, which is equal to negative 2. Okay. And how about number 3? If a is equal to 0, that means that here, right, suppose that here we have a times x. We are talking about this inequality, right? And I'm saying that if a equals 0, what does it mean? If a equals 0 means our equation becomes, here we have 0 times x, right? And here on the right, I have, then here we have b, right? So 0, uh, okay. All right. So here, if a is greater than 0, right? Here we have a is equal to 0. Here we have 0. And we are saying that on also this b is greater than or equal to 0, right? So what does it mean? Here, actually, if I just put one condition here, I have here 0 times x, and put something here for b. For example, let's say 5. 5 is greater than or equal to 0, right? Is 0 greater than 5? No. In this case, actually, the inequality has no solution. Okay, so that means that because on the left we have 0, on the right we have a number that is greater than 0, right? So that means that what less than 0. Now, a is equal to 0. So on the left we have 0. On the right we have a number that is greater than 0. But inequality is saying that we are saying that 0 is greater than a number which is greater than 0. That is contradiction, right? So because 0 is greater than only negative numbers. So at that time, actually, the inequality has no solution. Anyway, if you are given this inequality, ax is greater than b, and if a equals 0, which makes the left-hand side 0, and b is less than 0, that means on the right we have negative number, then the solution set contains all the numbers. Why? Because on the left we have 0, right? A equals 0 means 0 times x, that's equal to 0. On the right, what do we have there? B. Where b is less than 0. And we know that 0 is greater than all negative numbers if b is a negative number, right? So that's why, what is the solution? The solution will be all the numbers. Because anyway, 0 times anything is equal to 0, and 0 is greater than any negative number. Anyway, guys, let's just immediately use this properties in questions. Solve, for example, 2mx plus 3 is less than 3x plus n 4x. So Zaylin, what are we going to do in the first step? we have to transform this into the form ax is greater than 0, I mean b, or ax is less than b. How can I do that? So here we have 2mx, all the terms that has x, keep it on the left, and also this 3, I should take to the right. So here we have minus 3x. Here we have x, here we have x. Less than, on the right, now I have n, and take this 3 to the right. So here we have minus 3. Now, what is a common factor here? X and x, common factor is x. I can write it as 2m minus 3 is, here we have x, less than n minus 3, right? So right now, I don't have information about this m and n. Here, we are solving this inequality for x, right? So, number one, so we should start here, right? Number one, how can I start this? First, I will just consider this case. 2m minus 3 is greater than 0. And if 2m minus 3 is greater than 0, right, I can divide both sides by 2m minus 3. At that time, if we divide both sides by 2m minus 3, on the left, we will have only x is less than, here we have n minus 3 over 2m minus 3, right? So actually now here, what we have here, 2m minus 3 is greater than 0 means m is greater than 3 over 2. So actually the solution of this inequality will be this, where I can just write here, where m is greater than 3 over 2. And how about n? N is any real number because we have no any condition for n. N can be anything, right? And how about the second case? The second case is, how about if 2m minus 3 is less than 0, right? And we said that if you remember, if we have ax is greater than b, right? And if a is negative, right? When you divide both sides by a, also the inequality sign changes. At the time here we have x is less than b over. So if 2m minus 3 is less than 0, now I should divide both sides by 2m minus 3. So here we have x will be greater than n minus 3 over 2m minus 3. Again, where, so 2m minus 3 is less than 0 means m is less than 3 over 2. So m is less than 3 over 2. And how about n? For n, we don't have any conditions. So n is any real number or arbitrary real number. And we have one more condition left. Let me just change the color here. What is it? Now, if you're talking about here, where for n, we have three possibilities. Number one is here we have, what is this? 3 over 2. When n is here, taken from here, when n is taken from here, how about if n is equal to 3 over 2? So let's say m is equal to 3 over 2, or let me just write it as 3 2m minus 3 is equal to 0. So which means that m is equal to 3 over 2, right? So at that time, if 3 to, what is it? 2m minus 3 is equal to 0. Uh, okay, guys, I need a little bit more space. Let me just divide here. 0. Here on the left, I have 0 times x, right? Because 2m minus 0 equals 0. So less than n minus 3, right? So now it depends on, what is it? It depends on this n, that is positive or negative. All right, let me just write, I think I can combine like this. So if 2m minus 3 is equal to 0, now here we have 0 is greater than, I mean less than n minus 3, right? Also, that means that here, what is it? If this number is negative, right? And we know that 0 is not less than negative. So we will have no answer. So here we have then no solution, no solution when n minus 3 is negative. That means that n is, what is it, less than 3. And here, the solution is all the numbers, what would we say that? All real numbers, when n is greater than 3. Okay, because as see here, if n is greater than 3, right, for example, let's say 5 minus 3 is 2. Is 0 less than 2? Yes. N equals 10. 10 minus 3, 7. Is 0 less than 7? Yes. So actually, when n is greater than 3, what will be the solution? Because x is gone here. X can be anything. But if n is less than 3, that will be contradiction. 0 is not less than negative number. At the time, it doesn't have solution. Okay, so we need to consider this 4 cases. Okay, Zaylin, Carl, everything okay?
Yes, everything.
Yes.
Zaylin, where do you study? It was school.
Myanmar International School. It's near Myanmar Plaza in Sedona.
Near Sedona, Yakin
Yes.
Center.
Uh, it's near like Inequality Estate.
Good, I see. Carol, how about you? Where do you study? Private school or public school?
I studied at a public school in Philippine Science High School in Quezon City,
So, Carol, you are grade 6 now or grade 7?
grade 7.
Good. Zaylin, also you're in grade 7.
Yes, I am also in grade 7.
Okay. Guys, did you ever study this topic before, linear inequalities?
Yes, but not with like a greater than less than signs.
So that means only equations.
Yes, only equations.
I see. I see. Okay. But that's also very similar, just you need to consider when it is greater than, less than, and the only difference is, especially if you divide both sides by a negative number, the sign changes. But all the procedures is very, very similar to solving linear equations. And also the difference is linear equation, it has usually one solution or infinitely many solutions or no solution. Also linear inequalities, usually they have infinitely many solutions. I mean, set of solutions, okay? Because if I say that, okay, to get a driving license, you must be at least 18 years old, or maybe in Myanmar, 16, I don't know, let's say 16 years old. So what numbers do you think of at that time? So that means that at least 16 means if your age is X, X must be greater than or equal to 16. So that means that you can be 16 or 17 or 18. How many people? A lot of people, right? Above the age, whose age is 16 or above 16. And it is something like this. Anyway, let's continue. Another example. Okay. If any value of x can also satisfy a times x minus 2 is greater than or equal to 3x minus b. Find the range of possible values of b, or value of b. What do we understand from this inequality? It's saying that if any value of x, right, that's the keyword, any value of x, that means that whatever you substitute for x, and if you just evaluate this, okay, it will be greater than the right hand side. Okay, so that means that number one, first we should just find x. Okay, number one is, okay, first let's solve this and bring this into this form, like a times x is greater than or equal to capital B. And after that, we will discuss this. How can I do this? Just simple manipulation. Remove the brackets. Here we have a times x minus 2 times a. Here we have 2a. Greater than or equal to, here we have 3x minus b. Now, if you take 3x to the left, ax minus 3x, right, is greater than or equal to, take 2a to the right, it becomes, it is minus, so it becomes plus, right? It is 2a minus b. Now here, as you see, x is a common factor. If we just take this out, here we have a minus 3 times x is greater than or equal to 2a minus b. Now, if you remember, this ax is greater than b, right? When that thing has, I mean, every x will be the solution of this inequality, right? If you remember, when is it? Number one, if capital A is equal to 0, that means that now 0 times x, I have 0 on the left-hand side. So 0 is greater than what numbers? And 0 is greater than any negative number, right? If and b is less than 0. At that time, whatever you substitute here, this inequality holds. That means that left-hand side will be greater than right-hand side, right? So for example, let's say I can just give you example 0 times x, right? If I just write here 5, not 5, negative 2. Zainin, if I ask you, that's an inequality. How many solutions does it have?
Um, 0. No solution.
Carol, how about you?
No solution as well.
It
I
has
guess
infinitely many solutions. So that's the question, right? For example, let's say x equals 1, right? And substitute there 0 times 1. And is it greater than negative 2? Yes, right? Because 0 times 1 is 0. 0 is greater than negative 2. So that means that x equals 1 is one solution. Let's say x equals 5. Check this. Here we have 0 times 5 is greater than or equal to negative 2. What is 0 times 5? 0. Is it greater than negative 2? Yes. So whatever you substitute for x, because of the 0, it becomes 0. And 0 is greater than any negative number. Right? So that means that this inequality has infinite solutions. So if we consider this case, what we have here. Now to do this one, so if every x is a solution, then this a minus 3 should be equal to 0, and 2a minus b should be less than or equal to 0. Because also here we have equal sign. If it is 0 left hand side, right hand side 0, that's also a solution. Okay, and all the solutions together, they form the solution set of the inequality. Okay, guys, let's continue. So how do you solve that? Now, if you solve this left-hand side, right, what we have here, so here we have a is equal to 3. So a must be equal to 3, right? Now from here, and we are saying that, now I know already the value of a. I have already found it. That's equal to 3. Now substitute here, 2 times 3 minus b less than or equal to 0. Now, if I just take it to the left-hand side, what is it here? B will be greater than or equal to 6. Okay. So what is the question? Find the range of possible values of B. Only it's asking about B. So the possible range of values of B is B must be greater than or equal to 6. When B is greater than or equal to 6, automatically there A will be equal to 3. And whatever you substitute for X, actually the X will be the solution. Okay, Zainin.
Yes.
All right, guys, let's continue then. Another example here. Solve the following inequality for x. Okay. Now, as you see here, we have a parameter that's a, right? That's additional letter is involved here. As you see here, let me change the color. Let's use green now. Now here we have a square, right? And on the left, what is example 5? 1 minus 2x over, it should be a, not x. I'm just change this quickly. Okay. It is not. So here we have x plus 3 over a squared minus 1, and is greater than 1 minus 2x over a for x. So that means that x is unknown, right? That we are looking for its values. And a is, we call this the second variable or just parameter, okay? So now the first thing, right, at the first glance, since the denominator involves a, right, we have to write this condition that a cannot be equal to 0. Why? Because if a equals 0, on the left hand side, something is divided by 0 that is undefined. On the right hand side, something is divided by 0 undefined. We don't have such number, right? We don't have such number, and we are talking about that number. It doesn't make sense. So that's why the first condition is a should be different from 0. Okay. Now the second condition is, not the second condition, since a is greater than 0, Zainin, can I just write this thing? Then a squared is always positive. Do you agree with me?
No, because like even if like it's a negative number, then the outcome will be positive.
No, what is a squared? Here, if a is non-zero number, for example, -2 squared. What is -2 squared? -2
Or
times -2 is equal to 4. Is 4 greater than 0? Yes. And
yes,
how about, for example, let's say this a is equal to 4. Then 4 squared, that's equal to 16. Is it equal to 0? I mean, greater than 0? Yes.
yes,
If a is non-zero number, then its square is always greater than 0. Okay. So I'm sure about this, never negative. Why? Because if you multiply a number by itself, the result will be always non-negative. But if I know that that number is not equal to 0, that means that that number is always positive. -2 times -2, 4. -3 times -3, 9. -5 times -5, 25. 2 times 2, 4. 5 times 5, 25. In each case, as you see here, the resulting number is greater than 0. And again, why am I saying this? I am going to use that property of the inequalities. What is it? If you remember, if, right, if a is greater than b and c is positive, right? If you just multiply both sides by c, right, a times c, the inequality sign does not change, b times c. Okay, so using this property, how about if I multiply both sides by a squared, because I know that a squared is positive number, even it's not equal to 0. And also I multiply the right hand side by a squared. So now just algebraic manipulation, if you simplify the left hand side, a squared times x plus 3 over a squared, that's equal to x plus 3 minus a squared times 1, that's equal to a squared, is greater than, and here we have a squared over a, right? What is 1 over a times a squared? That's equal to a, right? Because a squared, I can just write it as a times a. These a's are gone, so that's equal to a. So on the left hand side, I have a, right? Because with this square, this is gone. A times 1, that is a, minus 2x times a, that's equal to 2ax. And next thing is, again, what are we, am I trying to do here is I am trying to change this into this form. Here we have capital AX is greater than capital B. Okay, I'm trying to change this into this form. Okay, it's just for draw calculation. So if we continue here, take minus 2ax to the left. So here we have x plus 2ax is greater than, and take the rest of the minus a squared to the right, 3 to the right. What we have here, a squared plus a minus 3, right? This 3 comes from the left hand side, changing the side, that's why also it changes its sign. So now, what is the common factor here? Here we have 1 times x. Here we have 2a times x. Take x out. So here we have 1 plus 2a times x is greater than a squared plus a minus 3. Carol, is everything clear? Do you follow me?
Yes, sir.
Okay. What is next, Carol? What should we do now in the next step? Okay, I need to consider two cases, right? Number one is, what is it? I will consider three cases. That's the first case, and this is the second case, and that one is the third case. So let me change the color and continue. That is our first case, okay? And here I'm just going to write the second case, and here we have the third case. Because the solution depends on, the sign of this capital A, right? The first one is suppose that 1 plus 2a is greater than 0. So that means that, what is it? A is greater than minus 1 over 2. What happens here? We know that if capital A is greater than 0, what is the solution? X is greater than b over capital A. So that means that from here, that x will be greater than x squared plus a minus 3 over 1 plus 2a. Or actually, 1 plus 2a is the same as 2a plus 1. Let me just write it in this order, 2a plus 1. That is the solution of this inequality. And also, what is a? A must be greater than minus 1 over 2, right? And how about the second case? The second case is, how about this 2a plus 1 is equal to 0? That means that this a is equal to minus 1 over 2. So if it is so, right, on the left we have, what is it? 1 plus 2a is equal to 0. Here I have 0 times x greater than, I don't know it's true or not, we're going to check this, okay? And we say that a equals minus 1 over 2, right? And substitute 1 over 2 for a. So here we have minus 1 over 2 squared plus minus 1 over 2 and minus 3. And on the left, if you simplify this, I have 0. On the right, here we have 1 over 4 minus 1 over 2 minus 3. And if you calculate this, this is negative number, right? And negative number is less than 0, always, right? So that means that, what is the solution then? All numbers, right? All numbers, all real numbers will be, what is it? The solution set contains all the real numbers. Okay, usually how they show that, usually it's just x is any real number. Okay, so that means that if a equals negative 1 over 2, the solution of this inequality contains all the numbers. And one more case is left. What is that case? Let's use now purple here. The third one is, when 1 plus 2a is greater than 0. We have already considered this case. 1 plus 2a is equal to 0. The third one is 1 plus 2a less than 0, which means that a is less than minus 1 over 2, right? So we know that if capital A is less than 0, when we divide both sides by a, also we need to change the direction of inequality sign. So from here, x, right, will be, I have to change this, less than a squared plus a minus 3 over 2a plus 1, where a is less than minus 1 over 2. At the time, this will be the solution of this inequality. Okay? Zaylin, Carol, any questions?
No, sir.
Are you sure? Okay. I will ask you a question soon. Okay, let's finish this. That is, let's see one more example, and after that, we will solve question from exercise 1. All right, another example. Find the value of k such that for x, the following equation has, we have three different questions here. Number 1, positive solutions. Number 2, negative solutions. Number 3 is C, solutions not greater than 2. Okay, so to solve this question, again, I need a little bit more space. So let me just draw from here one line, another line here, Okay. All right. Let's use now, I don't know, we use black. We didn't use black. Okay. So first we need to solve this equation. Number one, the first step. Okay, first let's just solve our equation. What is that? What does the solution look like? So if you just solve this, here we have 3 times x minus 3 times k. On the left, here we have x plus k plus 2. Now here we have unknown, we should take to the left, right? So here we have 3x minus x. On the right, k plus 2. And this 3k to the right, it is plus 3k. 3x minus x is equal to 2x, right? Is equal to k plus 3k, that's equal to 4k plus 2. Now, if I just divide both sides by 2, what we have here? That x will be equal to 4k plus 2 over 2. Now, if we simplify this, 4 over 2, that's equal to 2k. And 2 over 2, that's equal to 1. Right? Okay, that is the solution of this equation actually in terms of k. So that x is equal to 2k plus 1. Now in the question, we will answer part A. What is part A? It says that positive solutions. So when that x will be positive, right? What is x? We already wrote here, x is equal to 2k plus 1. When is it positive? If you just solve this, take one to the right, right? So here we have k is greater than negative 1 over 2. So that means that when k is greater than negative half, the solution of this equation will be positive. Okay, so again on the number line, here we are talking about k. This is a k line. Here we have minus 1 over 2. If you just pick any number from the right, not inclusive, and substitute there, solve the equation, the solution of this equation will be negative. The second case is okay. The second one is B. It says that negative solutions, right? Negative solution means that what is x? X equals 2k plus 1. Negative means it should be less than 0. Negative means less than 0. So again, if you solve this, what we have here, k is less than minus 1 over 2. So that means that when k is less than negative 1 over 2, the solutions of this equation will be negative. And the last one, C, solutions not greater than 2. What does it mean? Not greater than 2 means x is less than or equal to 2. So what is x again? Our x is 2k plus 1 less than or equal to 2. Not greater than 2 means less than or equal to 2. So we have to solve this to find the values of k. Take one to the right hand side, right? 2 times k is less than or equal to 2 minus 1, that's equal to 1. Now divide both sides by positive 2, so k will be less than or equal to 1 over 2. So when k is less than or equal to 1 over 2, the solutions of this equation will be not greater than 2. Okay, Carol, Zai, Mateo. Mateo, welcome. I think he's also from Philippines because of the flag, I think. Mateo, are you there? Okay, I think maybe he's busy. Zaylin, any questions so far?
No questions, sir.
Zaylin, are you good in math at school or just normal student?
Um, I think I'm good with math in school.
Very good. Carol, how about you?
And in our school, I think every one of us are good in math. So I think I'm also good in math at school too.
Yeah, I mean, when I say you are good, usually in math exams, do you get the highest score in the class?
No, I mean most of us in our school are also good at math, so it's also gifted students there.
Hmm. No, usually, for example, out of 100, how much do you get in math exams?
Probably 80. Some
80.
I get, yeah, 80 to 100, so it's mostly
Hmm.
high.
So your math score usually is greater than or equal to 80. Is that so?
Mm, could be.
Zaini, how about you?
I've never gotten less than 95.
Good. Very good. If you're good students, very good. Now, guys, in exercise 1, we have a few questions. How many? I think we have around 15 questions. Okay. Let's solve them, some of them, as much as we can. Maybe next week, and after that, we'll continue. Exercise 1, question 1. It's not question 11, it's 1. So given a plus 1 equals b minus 2 equals c plus 3 equals d minus 4. Arrange A, B, C, and D in ascending order. Ascending order means from the smallest to the highest, right? Moving up. Descending order means from the biggest to the smallest, moving down. So now from here, okay, let's just do one, one by one. Here, A plus B, right, is equal to B minus 2, right? So if I just subtract, for example, 1, right? For example, here, A plus 1 is equal to B minus 2. So that means if I subtract 1 from both sides, A plus 1 minus 1 is equal to A. Now here we have B minus 3. So if you subtract 3 from B, then actually that's equal to A. That means that what is B? B is greater than A. That's our first observation. Okay, so A is smaller, less than A. The second one is, how about if you compare this B and C? So B minus 2 is equal to C plus 3. If you just add 2 to both sides, so here we have B minus 2 plus is 0, C plus 3 plus 2, that is C plus 5. So that means that if you add 5 to C, then you get B. So that means that B is greater than also C, right? Okay. So now, all right, B is greater than A, greater than B. That means that actually B is A and C, I don't know yet. How about C and D? Okay, B and C. After C and D, C plus 3, you are adding, and D minus 4. Also from here, if you subtract, for example, 3 from both sides, C will be equal to D minus 7. So if you subtract 7 from D, then is equal to C. That means that D is greater than C, right? So, okay, B is greater than C, B is greater than A. All right, B is greater than to both, right? That means that uh, D is greater than C. But I don't know if B is greater than D or not. Okay, in other way, all right. Okay. All right. So B is greater than A. B is greater than C. Okay. So D is greater than C. Now let's compare B and D. How about B and D? Here we have B and D. B minus 2 is equal to D minus 4. So if you add 2 to both sides, B, because minus 2 plus is equal to 0, D minus 4 plus 2, D minus 2. Now from here, if you subtract 2 from D, then is equal to B. That means that D is greater than B. So that means that here, let me just write our draw number line. Here, actually, we have D, right? And B is greater than A, greater than C. So here we have B, right? And now I need to compare A and C. And A and C is here. A plus 1 is equal to C plus 3, right? Or if you subtract 1, A is equal to C plus 2. So that means that if you add 2 to C, then is equal to A. That means that A is greater than C. So here we have A and here we have C. So the answer is, if we compare these numbers, C is less than A is less than B is less than D. So we just arrange these numbers in um, ascending order. Another example, given A is less than 0, that is negative number, and minus 1 is less than, B is less than 0. That means that B is between minus 1 and 0. Arrange A, AB, and AB squared, right? How do we do that? For example, A is less than 0. How about AB? Okay. A, I know is less than 0. That's not part 1. Part 2, minus 1, less than 1, less than 0, right? And I'm going to get AB here. So if you multiply all sides by A, what happens here? If, as you see here, A is negative. If you multiply all sides by A, also we need to change the inequality sign. So negative 1 times A minus A. I need to change the inequality sign. A times B, here we have AB. Change the inequality sign. And 0 times A, that's equal to 0. So that means that AB is greater than 0. So A is negative, right? So that means that AB is greater than A. That's our first observation, and that's our first conclusion. Number 3, how about AB squared? To get AB squared, let me just continue here. Multiply this one by B, this one by B, this one by B. Again, we know that B is negative number. So here we have minus A times B multiplying by negative number. We need to change the inequality sign, less than A times B times B. That is AB squared, less than 0 times B. That's equal to 0. So that means that AB squared is negative number, right? And how can I compare with AB? As you see here, AB is positive number. Now here we have AB squared is greater than minus AB, right? How can I compare with AB? AB is positive number, so that is okay. All right, AB squared. Okay. No, just I think we need to compare with, because AB is positive, right? AB squared is negative because A is negative, B squared is positive, it's negative. So for sure, also AB is greater than AB squared. Now we have to compare A and AB squared. So to do this one, A is okay, negative, AB squared is negative, but multiplying by B squared. Okay. So I should just compare this A and AB squared, right? How can we do this? Uh, Using this one, if you multiply by, okay, by, what is AB? Okay, minus A. All right. So guys, here, we know that B squared, right, is greater than, I mean, okay, B squared is less than 1. Why? Because B is between negative 1 and 4, right? If you just pick any number from, from this interval, its square will be less than 1. Just example, for example, let's say here we have negative 1 and here we have 0. What numbers do we have here? For example, minus 1 over 3, minus over 1 over, not like this. Okay. Here, let's say minus 2 over 3 or minus 1 over 3. Maybe here we have minus 1 over 2. What is minus 2 over 3 squared? It is 4 over 9, less than 1. What is minus 1 over 3 squared? It is 1 over 9, less than 1. Anyway, if you just pick any number between negative 1 and 0, or 0 and 1, doesn't matter. If you square this, the result will be less than 1. So considering this, Okay, considering this, now b squared is less than 1. So I'm going to compare ab squared with a. So if I multiply both sides by a, what happens here? A is negative, so a times b squared. I need to change the negative inequality sign because we are multiplying by negative number greater than 1 times a. So that means that ab squared is greater than a. So now that means that ab is greater than ab squared is greater than a. So it says it in descending order, right? From the largest to the smallest. So that is in descending order. The largest of these numbers is ab. The smaller one is ab squared. And the smallest one is a. Mateo, are you there? Yes. Okay, Mateo. Carol, Zion, Mateo, any questions, guys? You don't ask any questions. Is everything clear?
Yes.
Okay, then. Another example. Let's solve 2 more examples, and after that, maybe we'll finish the class. Solve the inequality. To solve this one first, we have to expand. Again, I am going to bring this into this form. Ax is greater than b. So here we have 2x minus 2 minus 3x greater than 4 times x. 4x plus 4 plus 5. Now 2x minus 3x, that's equal to minus x. Here we have minus 2. And simplify the right hand side. Here we have 4x plus 9. Now take 4x to the left, minus x minus 4x greater than. Take negative 2 to the right. It is 9 plus 2. Minus x minus 4x, that's equal to minus 5x greater than 9 plus 2, 11. Now that's multiplied, right? So if I divide both sides by negative 5, it's negative. That's why we need to change the inequality sign. So here we have minus 5 times x and 11. I'm dividing by negative 5, dividing by negative 5. Because of negative 5, I need to change this inequality sign. It will be less than. So this negative 5, it is gone. So here x less than minus 11 over 5. So all the numbers which are less than minus 11 over 5, right? Here we have minus 11 over 5. All the numbers to the left of this number will be the solution of this inequality. What does that mean? If you just pick any number, for example, what we have here, minus 3. What we have here, minus 5. What we have here, minus 7 or minus 8. If you substitute and evaluate the left-hand side, right? And also substitute and evaluate the right-hand side. So this left-hand side will be greater than left-hand side. Okay. Another example, solve. Okay, so it involves fraction. In the denominators, here we have 3 and here we have 2, and least common multiple of 3 and 2 is 6. So let me multiply both sides by 6. So here we have 6 times x plus 1 over 3 minus 6 times x minus 3 over 2 greater than 6 times 5. 6 times 1 over 3 is equal to 2. 2 times x, it is 2x, plus 2 times 1, it is 2. Minus 6 times 1 over 2 is 3. Negative 3 times x, negative 3x. Negative 3 times negative 3, it is plus 9. A lot of students make a mistake. You should be careful. We are multiplying minus 6 by these numbers, right? So greater than 6 times 5, that is 30. This is times. So now simplify 2x minus 3x, that is negative x. 2 plus 9, it is plus 11, greater than 30. So minus x is greater than 30 minus 11, which is equal to 19. Now we need to leave x alone, right? So I'm going to multiply both sides by negative 1. Negative 1 times negative x, that is x. We are multiplying by negative 1. That's why I need to change the inequality sign, less than. 19 times negative 1, that is minus 19 or negative 19. So all the numbers to the left of negative 19. Right here we have negative 19 will be the solution of this inequality. Altogether, they form the solution set. And how about this example? Again, just we need to simplify, right? And after that, do this. So again, here I have 3 and I have 4. Least common multiple of 3 and 4 is 12. Let me multiply both sides by 12. So 12 times 1 over 3, I have here 4x minus 3 times 12, that is equal to 36, plus 12 times 1 over 4 is equal to 3, 2x minus 6 greater than or equal to 12 times minus 3x minus 36x, right? So now let's simplify this. 4x minus 36, 3 times 2, it is 6x minus 18, greater than or equal to minus 36. Now if you simplify this, 4x plus 6x, that is 10x minus 36 minus 18 minus 54, greater than or equal to, still I have on the left minus 36x. Now minus 36 we should take to the left, so here we have 10x plus 36x, greater than or equal to, take negative 4 to the right, so it will be positive 54. 10 plus 36, 46x, greater than or equal to 54. Now we should divide both sides by 46. It's positive, so it does not change the inequality sign. What is x greater than or equal to 54 over 46? But if you just leave this in this lowest term, 54 is 2 times 27, and this one is 2 times 23, which is equal to 23 over 27 over 23. So dot, 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 the solution set of this inequality is all the numbers that is greater than or equal to 27 over 23. Okay, Carol, Zaylin, Mateo, any questions? All right. And like this, we have more questions. Okay, actually, we did the similar question. Now we are running out of time. So, guys, nice to meet you once again. Maybe, I don't know. I think I'm going to meet you again next week. Okay. So, have a look and try some questions from exercise 1. I think you already got material from your, that's this Olympiad organizers. Okay. So we will continue next week. Until next week from this exercise 1, if you have any questions, also bring them. Maybe we can discuss together. Okay. So thank you very much. I wish you good luck, and I will see you, or we will meet next week. Okay, Carol, Zaylin, Mateo.
Bye, sir.
Bye bye. Bye bye. See you.
Bye.
Bye.